There are three steps that you can follow. First, you write a balanced chemical equation with state symbols. Then you break down all the aqueous compounds into their respective ions. Now, aqueous means it is not a solid or liquid or gaseous state. It has to be bracket AQ. So writing state symbols in the chemical equation is important for you to identify all the aqueous compounds. Now, compounds means that you leave all the elements alone. For example, chlorine, iodine, magnesium, all these are elements. You leave the elements alone. You do not need to break down any elements. And the third step, the last step, is to cancel identical, which means same ions. They are present on both sides of the equation, on both sides of the arrow sign. That means whatever on the left and right side, if they are the same, you cancel them away. Now, some common ionic equations that you need to know how to write are acid-alkaline neutralization reactions, ionic precipitation reactions, and displacement reactions. I'll show you some example of each. Okay, this first example, you can see on the corner here is neutralization reaction between acid-alkaline. So you look at all the aqueous. This is aqueous, aqueous, and aqueous. So you leave the water alone. Now, you break them down into the ions that make up this HCl. So in aqueous state, what you have in the solution is H plus and Cl minus ions. And sodium hydroxide is Na plus and OH ions. And NaCl is Na plus and Cl minus ions. Now, you compare both sides of the equations, you realize that sodium is present on the left and the right. Chloride is on the right and also on the left. So you have H plus bracket aqueous plus OH minus aqueous give you H2O. You basically bring down whatever is left, and this is the ionic equation. And you soon realize that this is the standard ionic equation for neutralization. Next example. This is another neutralization reaction between sulfuric acid, potassium hydroxide to form a salt and water. So you leave the water alone. H2SO4 is broken down to 2H plus. Take note, there's no such thing as H2 plus. The 2 here means they are basically 2 hydrogen ions with each sulfate ion. So you break down to 2H plus and 1 SO4, 2 minus. Then potassium hydroxide is 2K plus. The 2 belongs to the potassium as well as to the hydroxide. So it's 2OH minus. And on the other side, 2K plus and SO4, 2 minus. So you compare both sides. K is on the right and on the left. Sulfate is on the left and on the right. So what's remaining is actually 2H plus plus 2OH minus give you 2H2O, which is actually not cancelled away, as you can see that. But 2 can further be reduced to the lowest term of 1 to 1 to 1 ratio. So you divide all by 2, you get H plus bracket aqueous plus OH minus bracket aqueous give you H2O liquid. That's all. And realize that this ionic equation is same as the previous ionic equation because all ionic equations for neutralization are the same. Next, let's try another one. This one you break down into 2H plus plus 2NO3 minus. This break down to Ca2 plus plus 2OH minus. And this one Ca2 plus plus 2NO3 minus. So compare both sides. Calcium cancel, nitrate cancel, and you get 2H plus, 2OH minus, and the leftover 2H2O. So reduce the simplest term, you get back H plus. Remember the state symbol aqueous plus OH minus equals, that gives you H2O liquid. And since it's a neutralization reaction between acid and alkali, you get back the H plus OH minus give you H2O. Next, we'd like to see some ionic precipitation. Silver nitrate and sodium chloride will form sodium nitrate and silver chloride. Silver chloride, as you know, is insoluble. So insoluble solid, you leave them alone, you do not break them down. So you break down the aqueous, silver plus NO3 minus. You break down Na plus Cl minus. You break down Na plus NO3 minus. Compare both sides of the equation. On the both sides of the arrow, sodium is present before and after. Nitrate is present before and after. All those present before and after do not take part in any reaction, so the spectator ions cancel them away. So what are reacting? So it's a silver plus bracket aqueous plus chloride minus bracket aqueous, forming silver chloride solid. Now this is ionic precipitation of silver chloride, but the reaction between silver ion and chloride ion. You soon realize that all ionic equation is very simple. You simply need to write down what is the product, and then you write the ions separately. That means silver chloride will become silver ion plus chloride ion. If it's lead 2 chloride, then you will get lead 2 ion and chloride ion. Let's look at the next example. Now in this ionic precipitation, the precipitate form is lead 2 sulfate. So this is what you have at the end, leave them alone. Let's break down all the respective aqueous compounds. Lead 2 plus nitrate, there are 2 of them. Sulfuric acid is 2H plus. Remember, don't write H2 plus, it's 2H plus because they are, these 2 means 2 hydrogen ions and a sulfate ion, and this is 2 hydrogen ion and 2 nitrate ion, because the 2 is for both hydrogen and for nitrate. So compare both sides of the equation. Let's cancel away the spectator ions that did not change after reaction. 2 nitrate cancel away, 2 hydrogen cancel away, and what is left are the ions that reacted. So Pb2 plus bracket aqueous plus sulfate 2 minus aqueous give you PbSO4 solid, and this is the ionic precipitation reaction of lead 2 sulfate. Next, displacement reactions. Now in displacement reactions, you realize all of them are aqueous. So should I break all of them down? No. All the rule says you break down aqueous compounds. So this Cl2 is not a compound, I2 is not a compound, so you do not break them down. You only break down the Ki to form 2K plus 2I minus, and the 2KCl is 2K plus 2Cl minus. So you realize that the only ion that has not participated in the reaction is 2K plus. By cancelling away this, the remaining need to be written in the ionic equation. Cl2 bracket aqueous plus 2I minus aqueous form 2Cl minus aqueous plus I2 aqueous. So do you realize that the chlorine actually went into solution and displaced the iodide so that iodine can be formed while itself become chloride. So this is a displacement reaction of a more reactive halogen displacing a less reactive halogen from the compound. Let's look at an example. Metals also can undergo displacement reaction. A more reactive metal can displace a less reactive metal from solution. So the elements are left alone. Aqueous compound broken down, copper 2 sulfate is copper 2 ion and sulfate ion. Magnesium magnesium sulfate is magnesium ion and sulfate ion. You realize that now it's a sulfate that has not taken part in the reaction, so cancel them out. So when you rewrite the equation, Mg solid plus copper 2 plus equals, you get Mg2 plus equals plus copper metal. This ionic equation clearly shows you that magnesium, being a more reactive metal, displaces copper from its solution, so you can get a copper metal while the magnesium becomes the ion. So this is the ionic equation of the displacement reaction.